Welcome to the lair of the Batty Boffin.
Hi there, Batty fans. Today we're going to be talking a little bit about the periodic table and particularly the Group 1 elements. Here's a quick reminder of where they come in the periodic table. So Group 1, all down the left-hand side, featuring famous things like sodium and potassium, lithium, we've got down there rubidium and cesium down at the bottom. But we're going to mainly be talking about lithium, sodium and potassium. And the fabulous thing is, of course, whatever happens with lithium, it works exactly the same with sodium, it works exactly the same with potassium. All of the Group 1 elements react in very similar ways with very similar outcomes. In an earlier video, I talked a little bit more about the Group 1 elements and their atomic structure and things like that there and the reactivity. So if you're not sure about that, go and check out one of the other Batty Boffin videos on the Group 1 elements, the alkali metals. Today we're going to find out why they're called the alkali metals. What we're going to do is look at 4 very common reactions. Their reaction with water, which you may know about, it's quite famous. Reacting with chlorine, burning, which is reacting with oxygen, and the very famous acid plus base or acid plus alkali at the bottom. So what we're going to do is we're going to start off by writing a chemical equation, and then you're going to find out what happens at the end of it. So to start off with, let's pick one of the alkali metals. Let's pick sodium. That's a really famous one. Sodium plus water. Noting that sodium, if you remember, again, if you're not sure about this, check out the earlier videos, sodium likes to form positive ions. It's desperate to get rid of one of its electrons, and it forms the Na plus sodium ion. Water likes to dissociate, and it splits into an H plus and an OH minus. So, with your knowledge of ionic bonding, I'm sure you can work out which bits join together with which bits to form the products. So pause the video and see if you can work out which 2 things come out of the end here. Hopefully you spotted that the sodium would like to join ionically with the OH, the hydroxide, giving us sodium hydroxide. And what's left is this poor old little H on its own. Well, that's hydrogen gas, but hydrogen gas doesn't actually hang around as H. It's a diatomic molecule. It hangs around as H2. That means we've got to do a little bit of balancing here. We've got 2 atoms of hydrogen there and another 1 there. So that's 3 atoms of hydrogen. We only actually put 2 into the equation. So we've got to do a little bit of balancing by changing the amounts. We've got to have 2 waters going in here so that we've got enough hydrogen. But that is giving us 4 hydrogens. So far we're only using up 3. So if I put, I'll move this arrow a little bit. If I put a 2 in front of there, we're now using 2 hydrogens here and 2 hydrogens there. That's 4, which matches the hydrogens there. The oxygens, we've got 2 oxygens going in and 2 oxygens coming out. So that's fine. The sodiums, we've got 2 atoms of sodium here, but only 1 there. So we need to double that as well. So there's your final balanced equations, and you should always balance chemical equations when you have them. 2 sodiums plus 2 molecules of water gives us 2 molecules of sodium hydroxide and 1 molecule of hydrogen coming off. Now, this reaction is a very vigorous one. All of the alkali metals react really quite vigorously with water, which is why they are stored under oil to keep them away from the air, which has got water in it. Also, of course, you never handle them because your skin's got water in it too and they would burn. But this also explains why they're called the alkali metals. Sodium hydroxide is quite a strong alkali. So all of them form alkaline solutions when you put them with water. They also give off hydrogen. So the next thing I'd like you to do is pause the video and tell me what the tests are for alkali solution and for hydrogen being given off. The test for an alkali solution is very easy. You just dip in some litmus or universal indicator paper and it should go that purpley, bluey, whatever colour it is, depending on how strong your alkali is. The test for hydrogen, you may know this one. You collect it in a test tube and you drop in a lighted splint and you should hear that classic squeaky pop sound. If you've never heard it before, go and watch some other videos. I might even do one myself on that. You'll know it when you hear it. So, any of the alkali metals react with water vigorously. This is an exothermic reaction. Here's a good word for you. Exothermic. Exothermic. It means gives off heat. And in fact, these are so exothermic that it will set light to the hydrogen it's giving off. It's so hot it sets light to the gas. And it will melt the metal. So you end up with a molten ball of metal whizzing around the surface of this, being powered by the hydrogen being given off in jets. So it's kind of jetting around and floating on a little pool of hydrogen there. It's kind of like a mini melting hovercraft. And the hydrogen's burst into flames. So you've got a hovercraft, you've got melted metal, and it's riding on a ball of flaming hydrogen. It's really quite good. Here's a photo. It's an awesome experiment. It's really good. Anyway, after all that excitement, let's see what happens with chlorine. Now, there I did the experiment with sodium. I could easily have done it with lithium or potassium. So the next one here, I think I'll use lithium. We're going to have little shards of lithium metal in the bottom of a test tube, and we're going to pass chlorine gas over the top. And as many of the gases here, it hangs around Cl2 as a diatomic molecule. So, pause the video and see if you can work out what that's going to turn into. It's pretty easy, really. Well, there's not a lot of option really, is it? It's lithium chloride. Lithium chloride, which is like sodium chloride, except it's lithium, and you can get potassium chloride. Sodium chloride, of course, is salt. We do need to balance the equation. We've got 2 Cl's here, and we've only got 1, so we need to have 2 molecules of lithium chloride, which means we need to put 2 lithiums in. So there's our balanced equation. The alkali metals react with chlorine to form salts. The sodium chloride is the one we call common salt, but there are other salts as well. This is another one. So that's pretty easy. Right, what about the reaction with burning? So the reaction with air. So what should we use? Potassium, we haven't used that yet. Let's have potassium plus oxygen, again O2. Now, when we do the bonding on here, we need to know a little bit about valency. Check out other Batty Boffin videos if you don't know about that. Potassium forms potassium plus ion. Oxygen, on the other hand, it's trying to add on a few electrons, so it forms negative ones, but it's double minus. It's short of 2 electrons. So oxygen effectively likes to form 2 bonds. If you imagine a little oxygen with a hand sticking out each side, potassium is only holding out 1 hand. So potassium, valency of 1, oxygen, a valency of 2. So that should give you some clues as to what they form. Pause the video and have a look at that. So potassium and oxygen simply forms potassium oxide. We need the 2 in there because oxygen likes to form 2 bonds and potassium only 1. Oxygen, there it is with its 2 bonds and a potassium on each side. There it is. It's a bit like H2O, but it's K2O. H, if you remember, is also part of one of the group bonds, so it's exactly the same as that. Just to balance it up, we've got 2 oxygens there, so we're going to need 2 molecules of that, and that means we're going to need, 4 of that, not 2. Woohoo! There we go, 4 of those, because we've got 2 K2s. Okay, so there's our balanced equation. Now this is a good equation because the burning of these alkali metals in air leads coloured flames, which is part of the flame test. It's also how we get coloured fireworks. Very distinctive colours. I'm just going to write them down here. We have lithium. Lithium has a bright red flame when you burn it. Sodium, a very distinctive colour. You may have seen low pressure sodium lamps. They have that kind of orangey glow, which does make things look weird underneath it there. But that distinctive orange colour is noting sodium. Whenever you see that colour, you know it's sodium. So it's that orangey, slightly peachy colour on there. And the last one, potassium, a rather fetching lilac colour actually, it's rather nice. So those are the colours that you will get of the flames when you burn lithium, sodium and potassium in oxygen. Worth knowing those. They're called the flame tests. And literally you get usually a little loop of nichrome wire, dampen it, dip it in the powdered whatever one of those, hold it in a Bunsen burner flame and you will see the flame turn lilac. If the flame turns lilac, you know you had a potassium compound there. Okay, flame turns red, you know it was lithium. That's the flame test. Very, very useful. The last bit down here, we have acid plus base, or acid plus alkali. So for this, we're going to pick any random acid, really, and any random alkali. Now, of course, the alkali metals are called that because they form alkali substances when you put them with water. So we'll use one of these, and let's have I don't know, hydrochloric acid, let's say. So there's our hydrochloric acid, which will dissociate into an H plus and a Cl minus. Plus our alkali, we're going to use sodium hydroxide. We could use lithium hydroxide if we wanted, sodium hydroxide there. And when you react those two together, basically the positive ions from there and the negative ions, they're kind of swap over. And you'll end up with two very well-known substances. So pause the video and fill those in, please. This one's really easy when you spot the answers. The H plus from there joins up with the OH minus from there, forming H2O. The Cl minus from there and the Na plus from there join together to form sodium chloride. Just plain common old salt, and it's all nicely balanced. Yep, 2 H's, 1 O, 1 A, yep, all nicely balanced there. Acid plus base equals salt plus water. And you could use lithium hydroxide, you'd get lithium chloride. You could use hydrofluoric acid and you'd end up with sodium fluoride. Any of them, group 1s and group 7s. So those are 4 common reactions. The 2 particularly important ones are the reaction with water, where it goes fizzing around and sets light to the hydrogen rather dramatically, and burning in oxygen, where you've got your flame tests and those distinctive colours. Now, there may be a video coming up shortly that's got some questions on the alkali metals, so I'll see you then, Vatty fans.